Hello and welcome to the last segment of our FS152. So we've looked at mass balance, energy balance or thermodynamics, fluid flow, and even a good number of unit operations. So now let's proceed to heat transfer. So katulad ng mixing, ang heat transfer ay isa ring common process no, or unit operation. This is not limited to just increasing the temperature but also those processes which decrease the temperature as long as the primary goal is to alter the temperature or increase the heat content of the food substance or increase or decrease rather. So gusto nating malaman, ano ba yung math behind heat transfer? What do we need to understand to be able to apply them to not just our daily lives, but our lives as food scientists dealing with heating and cooling in the large scale. Of course, don't expect any very deep stuff, no? So, mababaw pa rin to kumpara sa ginagawa ng mga engineers na nag-google ng um, like maraming panahon. So some of these topics we're covering for just 1 week, they cover in one sem. So it will not be the same. So bago ang lahat, may technical tayong term, no, yung heat exchangers para sa mga industrial equipment na ang primary purpose ay heating and cooling of foods. Okay, there are two major types, the non-contact and the contact type. When we say non-contact, obviously, yung heating or cooling medium mo, wala siyang direct contact doon sa sa food material mo. Okay, so example nito for yung halimbawa in double boiler mo pag nagluluto ka, the heating medium, which is the water in the first pan, is not in physical contact with whatever is being heated in the inner pan. On the other hand, yung contact type, isipin nyo na lang yan, pag nagsisteam kayo ng siomai, okay, yung heating medium mo, which is the steam, may nangyayaring interchange no heat and mass transfer na simultaneous, whereas with the non-contact type, purely heat transfer yung nagaganap. So we'll look at a few of these heat exchangers commonly used in the industry. Sa 2 taon ko nagtrabaho sa pabrika ng ice cream. It was only after I left and started teaching that I realized that it was a plate heat exchanger yung ginagamit namin for pasteurizing the ice cream. So we had one plate heat exchanger for the whole plant. Okay. Doon sa batching area. And doon dumadaan lahat ng ice cream na binebenta namin sa Pilipinas. Amazing, di ba? Alright, so it's called a plate heat exchanger because there are a series of stacked plates, as you can see here. What happens is that the heating or cooling medium and the food product flow on alternating plates. So kung the even number plates, nandyan yung mga heating medium. Sa odd numbered plates naman, and andun yung food product. Okay, there are videos in the next few slides to be able to see these in detail. So hindi naman kalakihan itong mga plate heat exchanger. These are probably, in this case, 1 meter or so in height. So maliit siya relative to what it can do. And it takes advantage of the very large surface area in between the plates and the fast flow rate of fluid to quickly heat up large amounts of liquid food or cool down in a continuous process. So let's watch the videos in the next few slides to find out more. So as seen in the previous video, when you look at the cutaway view of the heat exchanger, it's filled with a lot of patterns that increase the surface area, makes the flow more turbulent, and in total, hastening the heat transfer as compared to when you have the flat plates of stainless steel. As we have seen, one of the major downsides of a plate heat exchanger is how easily fouling could occur. Fouling decreases the heat transfer rate by having a less conductive material cover the surface of your stainless steel, as well as by increasing the thickness. And it may also cause pressure drops over time because there are parang sumisikip yung daluyan niya. Tapos syempre, yung fouling pattern, hindi naman yan regular. Okay? And that's also why you need to sometimes dismantle the whole system to manually clean the plates. No? So clean out of plates ito COP. Now, there are cases wherein regular CIP kaya naman matanggal to a certain extent yung fouling, pero aabot sa point na kailangan mo na siyang baklasin para linisin at i-inspect din. Okay? So, hindi kayang forever CIP lang because of its design. No? So, other than the advantages mentioned in the video, it is possible to heat or cool within 1 degree Celsius of the heat transfer media. No? So, you can actually adjust the parameters to fit kung ano ba yung process schedule mo, so to speak, whether it's heating or cooling. So I think I've discussed this before, but again, how does regeneration work? So when you have a heat exchanger, of course, typically you have a hot fluid and a cold fluid and entering, and there are times wherein ang nangyayari is the hot and cold fluid are the same, no? So yung halimbawa mag-iinit ka ng isang food substance, yung portion ng heating medium mo is also the food substance itself, no? So, yung mas mainit na fluid na pasteurized na kailangan palamigin, yun naman yung ginagamit para painitin yung malamig na fluid. So, in this case, you pasteurize fluid at 38 degrees to 88 degrees Celsius. As you can see, it goes through different segments of the heat exchanger. The temperature increases. Okay, and then at the same time, dun sa cooling process niya, makikita mo, kasi kailangan pag na-pasteurize, rapidly din siyang i-cool to around refrigeration temperatures or close to 0 degrees Celsius. No? So, there are certain heat exchanger designs wherein yung na-pasteurize nga na fluid is also being used to initially heat up the cold fluid. Of course, there may be cases wherein you would need to add another heating or cooling medium for the next phases of the heating or cooling process. So the next type of heat exchanger is called a tubular heat exchanger for obvious reasons. Para siyang concentric tubes wherein one of the fluids will flow through the inner tubes and the other fluid will flow through the outer tube. Similarly, this can have parallel flow or counter flow. So medyo simple lang naman yung design niya. But it's also possible to have it in a triple pipe design. So obviously in the triple pipe heat exchanger ay meron kang tatlong pipe, yung dalawa nasa loob ng isa, tapos yung pinakaloob nandun sa gitna, okay? So in this case, the product then is sandwiched between the heating or cooling media. Nasa gitnang pipe yung yung pagkain mo. And of course, ang advantage ito over the double pipe design is mas mabilis yung heat transfer na kayang gawin for the same size of the system. So ito naman yung shell and tube heat exchanger, very self-explanatory. You have an outer shell for one of the fluids and an inner tube or multiple inner tubes where the other fluid can flow. So again, this is still a non-contact type. And because you have many smaller tubes inside, you can also increase the surface area for heat transfer. So scraped surface heat exchangers can be used for both heating and cooling. This in particular is the one we use for making ice cream in a continuous process, no? So what it does is as heating or cooling occurs, you have some sort of wiper blades over here that scrape the surface of the pipe, usually where the product is flowing through. Para ito ay kung cooling siya to below freezing, para hindi mag-build up yung ice crystals. Kung heating naman siya, para ma-prevent yung pag-burn ng food particles doon sa surface. So of course, this would allow a wider range of temperatures to be applied, no? Typically kasi you don't want to go much higher than boiling point kasi nagsa-scorch na yung mga products. Pero kung nagsa-scrape ka, you can minimize or prevent that sticking of products at high temperature. Okay. So, as you can see here, may cutaway view tayo. Ganun din siya, meron ding concentric layers. So typically, the scraped surface is part is where the product flows, and meron siyang jacket for the heating or cooling medium, which is pwedeng steam, pwedeng water, or kung cooling, yung mga refrigerants ninyo. So finally, we have the steam infusion heat exchanger, which is one example of the um, contact type heat exchangers. So this is used for fluidized food, meaning to say kung halimbawa kung liquid man siya, it is turned into droplets, maximizing the surface area for heat transfer of the individual um, food particles, or kung parang powder man siya, kung sakaling solid siya, no? The advantage, of course, is the very high rate of heat transfer and very fast process na kung ano man yung gusto mong maganap during the process, mangyayari yan in a matter of seconds, no? By the time bumagsak yung food mo dun sa bottom, tapos na yung desired heating process mo. Okay, of course, this is also a type of continuous process. Okay, and you can somewhat control the temperature difference desired, of course, by controlling the flow rates of the product and steam, and the let's say the steam quality. No. Okay, let's take a sort of break from me talking. When we were doing things face to face, I used to have this activity wherein magdadala ako ng mga ball pit uh, plastic balls, and I'll ask the students to uh, group into 3 groups and illustrate kung paano yung heat transfer na gaganap. But since we can't meet face to face, and visualization is also one of our course outcomes, then i-visualize nyo na lang ito. I-try nyo i-drawing, isipin nyo, no? So imagine nyo kung paano ba talaga nagaganap yung conduction, convection, and radiation. We've been taught this since elementary perhaps, but we want to be creative with our minds and see how does this happen. Okay, so imagine if yung mga molecule ay mga tao, and then yung mga bola na hawak-hawak nila ay heat. If you were to transfer heat from one end of the room to the other, illustrating conduction, convection, and radiation, how would that happen? Okay, so I'd like you to think about that. Okay, the next slide will be blank, and I'll give a short uh, answer after. So, tingnan nyo na lang. Okay? Okay, so hopefully ganito yung naisip nyo. alam natin na conduction happens when molecules, usually solids, na magkakadikit, transfer heat by passing the heat from one molecule to the next thing adjacent without skipping. Also, at the same time, as they receive heat, they vibrate, and as they receive heat, they vibrate some more. So usually the students would end up doing something like that, and then habang bumibilis yung heat transfer, bumibilis din yung galaw nila. Okay. So in convection, we know that the molecules move around the water, no, and not just the heat. And as one molecule receives heat, so we know that warm fluid rises, whether it be air or water. Pag uminit yung molecule na yun, naiaangat siya. However, it dissipates that heat as it goes up. And thus, when it loses all its heat, babalik siya sa baba, and that's how you make your convection currents. Okay? Nakikita natin madalas na cycle. Alright, so that's what happens until eventually yung buong area na yun na may fluid ay more or less uniform na in temperature dahil sa continuous convection ng molecules. Radiation, on the other hand, is something, a phenomenon that occurs because anything that has a temperature above 0 Kelvin emits radiation. So this is different from the radioactive radiation. No, it's just radiating heat per se. And that happens, so one way siya. Yung nag-radiate na bagay, it could happen even in vacuum. So it transmits its heat, no, without molecules mediating in between. So whereas dun sa conduction and convection, makikita natin na yung heat ay nagta-travel na dala-dala ng molecules dito, the heat themselves can travel without the molecules, and hence nagbabatuhan yung mga tao ng bola. Okay? Meron sana akong video nito on file, no? Pero syempre hindi ko naman pwede ipakita for data privacy reasons na nagwawala yung mga upperclassmen ninyo, nagbabatuhan ng bola at tumatakbo-takbong may dalang bola. Alright, so anyway, we'll discuss these heat transfer mechanisms in the latter part of this module. And may accompanying equations na yun. That's why we have to very easily visualize what happens at the molecular level. Let's discuss some thermal properties of food. You're all familiar with specific heat since your early chemistry days, so we'll skip that. But again, this is just to realize that food as a substance, no, is a material that has thermal properties, and therefore we should take advantage of these thermal properties in, or rather take them into consideration when we are doing our food processing. So whether we're just simply cooking at home or in a plant and asked to help out with some issues in food processing, at least we know some things, no? The thermal conductivity K determines the rate at which heat will pass through a given substance and therefore proceed, no, to the next part. So for example, kung meron kang niluluto sa isang kawali, yung apoy mo, may barrier na kawali sa pagitan niya at ng food, and the thermal conductivity of that kawali will determine how fast or slow your food will cook. No? So for the same stove setting, the same amount of food in the pan, if your pan is the same substance but is thicker, then it will take longer for the food there to cook. Similarly, you're less likely to burn your food because the rate of heat transfer is lower. So the higher the thermal conductivity is, the faster the heat transfer will occur. Notice, for example, that this is stated in watts per meter degrees Celsius or Kelvin. So thermal conductivity in watts, and it's also dependent on the thickness of the material kasi tatago siya from one end of the material to the other, and the temperature gradient. So kung mas malaki yung difference ng temperature mo from one side to the other, so let's say you started with the food at room temp and then whatever the temperature of the flame is, no? So yun yung magde-determine ng thermal conductivity value mo. Therefore, in a sense, it's part of the system. Although intrinsic value yung conductivity ng material, we factor in both the thickness and the delta T in the equation. So it varies slightly with temperature. Again, in general, though, we use one value for thermal conductivity over a wide range of temperatures. And then in terms of food, thermal conductivity of food, you can actually estimate the thermal conductivity of that food material based on the mass fraction of yung sa proximate composition niya, carbohydrate, protein, fat, ash, and moisture. Of course, again, this is an approximation and does not take into account such things as aeration. No? So for example, if you have dough versus umalsa na tinapay, even if they have the same composition, yung hangin air cells, of course, will cause a difference in the conductivity somewhat. No? But then again, that's a different story. So here we can see the thermal conductivity of selected food materials and food insulating materials and food contact surfaces. No? So makikita natin sobrang laki ng range. Right. So although for food materials, typically it's less than 1. Alright, and maraming factors nag-affect niyan. So say hello to food physics. Of course, when you have granules which are actually suspended in air, then definitely the air contributes to the realistically lower conductivity, no, kung bakit hindi agad madaling matunaw yung asukal despite it being in direct contact with the pan and there being very little sugar involved, for example. So as you know, air is an insulator per se. Although, of course, this is as a conductor. Pero kung may convection nagaganap, syempre the convective heat transfer will kick in. Okay, and obviously, mas mabilis yung heat transfer kapag may convection. And nonetheless, for all the other solids, so we could see here, this is why silver is being used in many electronics because of the very high conductivity. Okay, used to be sa food industry ginagamit yung copper, but of course there are issues with it being a food contact surface. Yeah, most of the insulators that we use have a conductivity value way lower than 1, no, like 0.1 or less. So these are polystyrene, also known as styrofoam, and PU foam usually ginagamit din minsan pang insulate, no? So generally, we use the appropriate material depending on the purpose. So we want highly conductive materials if our goal is fast heat transfer. And on the other hand, if you want to preserve the heat such as yung mga cooler ninyo, yung mga refrigerator, gusto mong hindi tumagos yung init, then you would want highly insulating materials. On the other hand, we have another term called thermal diffusivity alpha, which is the ratio of the thermal conductivity over the density and specific heat. So on the numerator side, we can see how fast it can transfer heat to its surroundings, and on the denominator, we could see how much heat it could contain for a given volume. Okay, so since density multiplied by specific heat tells us how much heat it takes to raise its temperature and how much mass is there for a given volume. Therefore, a substance with high thermal diffusivity is something that has high conductivity but at the same time has very low specific heat and relatively low density, no? So, ginagamit natin ang thermal diffusivity para malaman in a way gaano kabilis mag-transfer ng heat yung isang substance and at the same time how much heat resides within it. So, therefore the substance with very high thermal diffusivity is that substance which transfers heat fast and does not store a large amount of heat and therefore madaling bumaba yung temperature niya. No? Kasi kung malaki yung heat storage mo, even if mataas yung conductivity mo, um, mabagal mag-drop yung temperature mo. Okay? Or increase, depende kung anong klaseng flow ang gusto mo, heating or cooling. So in a multi-component system, we can approximate the thermal diffusivity using this equation. Alright, so again, we saw that there are at least three different modes of heat transfer: conduction, convection, radiation. What do they have in common? Of course, is that what they do have in common is that heat is transferred from the hotter to the colder part. Okay, and we want to look at the resistance to heat flow dun sa mga materials na yun in understanding um, how heat transfers between one material to the other. So we start with conduction, which is defined as a kinetic energy transfer from one molecule to another adjacent one without resulting in particle displacement. You can look up these theories, so we will not be discussing them anymore as to how conduction happens. Nonetheless, what's important to know is that the rate of heat transfer is dependent on the wall surface area, or let's say yung pan mo or whatever it is na nagsaseparate dun sa hot and cold side, the temperature difference between the two sides of your wall, and how thick that wall is. So to illustrate, you can see here an example of the wall. So this may be yung insulation ng refrigerator mo, or kung itumba mo siya, yung thickness ay yung pan mo with a certain thickness in an area. So the rate of heat transfer here would be dependent nga on the factors how big the surface area is. More heat can transfer for larger surface area. How large the temperature gradient is. Pag mas malaki yung delta T, mas malaki yung heat transfer. And kapag mas makapal yung wall, mas mababa yung rate of heat transfer. And then, of course, the thermal conductivity K is the one which ties these all together. So it is the proportionator, no, that determines the rate of heat transfer. So the negative sign in this equation only indicates yung direction ng heat transfer mo. So in terms of magnitude, yung magnitude naman usually yung tinitignan natin kasi the direction is reversible. Depende lang kung ang tinitingnan mo is yung hot side ba or cold side. So in this problem, for example, we have a stainless steel plate 1 centimeter thick. Okay, visualize nyo yun. And then it's maintained that one side is 110 degrees and the other is at 90. So assuming steady state conditions, you are asked to calculate for the rate of heat transfer. Take note, in this case, per unit area, meaning to say we will assume that A is 1 square meter. Okay. And then you will add that to the denominator so that you can multiply it by any area to get the actual rate of heat transfer. And then you're given a conductivity for stainless steel that is 17 watts per meter degree Celsius. Okay, so simple plug and play lang naman ito. Of course, the negative sign would be dependent on whether your delta T is 110 minus 90 or 90 minus 110. Pero since we're after the heat transfer naman, well, arbitrary na yung sign as long as we know the magnitude of the heat transfer, no? So, of course, you can, if you plug in the values, you're bound to get 34,000 watts per square meter of the steel plate. Of course, varying any, changing the material, changing the thickness, or changing the temperature gradient between the sides would change the heat transfer value, no? Alright, continuing on, kung mapansin niyo iba na yung background ko, I am at my parents' house so that I could continue working during office hours without the toddler being heard in the background or being seen here on front. Okay, so nonetheless, let's continue with convection. So we know for a fact that convection is both heat and mass transfer at the same time. So sa conduction, alam natin na technically in place lang yung mga molecules, pero sa convection, they always move around depending on the heat content. So we have two types of convection, forced convection and free convection. So um, free, no, yung natural convection na tinatawag natin. Forced naman kapag let's say meron kang external force like yung mga convection oven na merong fans or blowers that move the air around. So that increases the convective heat transfer rate by a lot compared to say hinayaan mo lang na yung hangin ang gumalaw because of the natural convective heating doon sa loob, no? Um, the heat transfer rate Q is proportional to the area where the heat transfer happens, and the difference in temperature between the surface and kung saan man yung gitna nung thing na yan. So typically, convective heat transfer happens in this case between yung wall mo kung saan nanggagaling yung heat, kung saan nagpa-pass through yung heat, and the fluid medium na umiikot-ikot as it heats and cools and transfers heat. Okay. So the proportionality constant is the convective heat transfer coefficient denoted by the small letter h. So unlike conductivity na yung mga heat transfer coefficient or conductivity coefficient ay fixed na. So sa convection, it is a range. So we will not go about determining them, but for the sake of our problem solving, we either assume a certain value for the convective heat transfer coefficient, or we solve for it given all the other givens on hand. Okay. If you can see here, no, ang laki ng range. Alright. So for example, free convection, depending on the conditions, could have as much as 5 times difference. Free convection pa rin yan, no? And in this case, forced convection can be more than tenfold yung difference niya from the free convection counterpart. And that is why we often use forced convection whenever possible. Kasi for the relatively small energy input, you get a drastic increase in the convective heat transfer coefficient. Alright, and as usual, typically air and water are the fluids most often used for convection because these are readily available, and as we can see, typically the highest convective heat transfer can happen when using water vapor, which condenses on the surface and thus causes a very rapid transfer of heat. Okay, let's look at a sample problem. Let's say there is a stainless steel or rather generic metal sheet plate separating a hot side and a cold side. If the surface temperature at the surface of the plate is 120 degrees Celsius and the ambient temperature, say in that room where the surface is facing is 20 degrees, estimate the convective heat transfer coefficient. So we'll use this equation, Q is equal to HA delta T. 120 degrees is the Ts, temperature at surface, and 20 degrees is a T infinity or ambient temperature in that area. Okay, the rate of heat transfer per unit area is actually Q over A. So Q over A equals H delta T, no? So to get the convective heat transfer coefficient H, we simply divide this by the difference in the temperature. Take note that in this case, whether Celsius or Kelvin yung gamit mo, it won't make much of a difference at all. No, kasi delta T yung kino-compute mo. If you convert this to Kelvin and convert this to Kelvin and subtract, the answer will still be 100 Kelvin. Alright? Since we're dealing with a change in temperature, an interval. Okay? So when we do that, okay, isolate H on one side, put all the other terms on the other, you would get a value of 10 watts per meter squared Kelvin. So what does this mean? Um, for each 1 square meter na surface area ng steel plate, ay nagtatransfer siya ng 10 watts sa kada 1 degree Celsius or 1 Kelvin na difference between the surface temperature and the ambient. Okay, so to increase the Q, you either increase the contact area, the surface area, or you increase the delta T. So that's how we understand this one. Pretty simple, pretty basic. Alright, so last is radiation or radiative heat transfer. Again, iba po ito dun sa radiation na alam natin dun sa mga nuclear weapons and all. Okay, those are, if you had your food physics, di ba? Emission ng mga radioactive particles and stuff. Okay, ito ay emission lamang ng electromagnetic waves or photons. Alright, this occurs without having any physical contact and thus is the only form of heat transfer among the three that can occur in vacuum conditions. Conduction cannot occur when there is no adjacent molecule, and convection cannot occur when there are no molecules to carry the heat in a vacuum. However, radiation can still occur. And because we're dealing with electromagnetic waves, things happen at the speed of light, so much in the same way that solar radiation passes through the vacuum of space to reach our planet and our skins. Okay. And at the same time, most gases, due to their very low density, are somewhat transparent to radiation. So basically, ang mas nag-a-apply ng radiation tayo sa solids and liquids. So alam naman natin yung radiation, of course, one good example is tumayo ka at maarawan ka, di ba? That's not conduction, that's not convection, but your body is being heated by electromagnetic waves, solar radiation. Okay, pagdating naman sa radiation, lahat ng bagay na above 0 Kelvin, um, whether it's a living or non-living thing, emits radiation in accordance with this equation, okay, where sigma is the Stefan-Boltzmann constant, experimentally determined. Notice that it's a very small magnitude, 10 to the minus 8. Therefore, yung nire-radiate nating init is relatively small in comparison to conduction and convection, no? Unless you have a very high temperature. Okay, then the emissivity is defined as the extent to which the surface is similar to a black body. This is a value between 0 and 1. A black body is a hypothetical object that absorbs all incident electromagnetic radiation. Then of course, there's the surface area, and yung effect ng temperature naman is exponential, the order of 4, no? So exponentially higher yung radiation at higher temperatures than at lower absolute temperatures. So here's another straightforward problem for radiation. Given that you want to calculate the energy emitted by 100 square meter surface area of some polished iron surface, you know that the emissivity value is 0.06 and the surface temperature is 37 degrees Celsius. So in this case, it's a simple, again, plug and play solution, as you would like to call it. The area is given at 100 square meters, the emissivity is given. Only thing we need to do is convert the temperature to Kelvin by adding 273 and then raising it to 4. Okay, so after that, you can calculate for the value of your heat transfer rate, which is 3000 watts. That's a lot of heat, but bear in mind that this is a 100 square meter iron surface. Okay, my house is just half that, alright, in terms of floor area. So ganun kalaki yun. Kaya pag ginawa mo siyang per square meter, then that would be just 30 watts. Medyo maliit na yon, no? Pero mainit pa rin yun in real life. So again, we're talking about radiation. So in reality, hiwa-hiwalay yung, or I mean, conduction, convection, and radiation could all happen at the same time. So up till now, we've only done very basic problems, but at least we've realized that these three modes of heat transfer often occur simultaneously. However, sometimes, let's say, radiation is less significant, such that um, we consider only the most significant part. Another time naman ay it may occur in series, so pwedeng conduction muna dun sa surface ng across the pan, and then dun sa surface ng pan it thus becomes primarily convection. So you can try to, the next time you cook something, think about what mode of heat transfer is being utilized, or if you maybe watch videos of food processing methods, ano yung mode of heat transfer. So marami pa tayo sa next module na part ng module for next week na titingnan for this one, no? And pati yung mga mas complicated na problems, heads up, ay nandoon lahat. Nonetheless, the applications would include refrigeration, calculating for insulation, yung insulators versus conductors, and maybe how do we basically design the heat exchangers, not the engineering level design, but at least we understand the mechanics, tapos kapaano yung difference kapag concurrent and countercurrent, the temperature gradient. So all of that will be looked at next week.